My name is Belle. I'm an assistant professor at Tongji University in Shanghai at the College of Architecture and Urban Planning. My field of research is governance and organizational studies from the perspective of an architect and geographer. My recent research is on blockchain technology in the architecture, engineering, and construction industry. I recently published a paper in the proceedings of the Conference of Digital Architecture, and since then I've been asked to give this talk over and over in different settings. So for all of you who share my passion in blockchain, I decided to record it so that you guys can look at it from wherever you are, join the conversation, leave comments and questions. There is this hype in the tech sphere. It's called the blockchain. It started in finance and it very quickly seeped into other parts of the industry, into economics, into accounting, and into insurance. Now, some observers see it as positively. They say it's going to transform society for the better. Others see it as a disruptive force, and they're very afraid about the market share that they have established for many years. So now my angle on it is from someone who's been doing research in architecture and human geography for the last 10 years, particularly governance studies and organizational studies. So when I first heard about the blockchain in finance, logistics, and the insurance industries who were at that time adopting blockchain technology, first thing that came to my mind is, cool, what can this new technology, what can blockchain technology do for my industry, for the architecture, engineering, and construction industry? Here you see a recent study done by McKinsey & Company on digitization of industries. And here you see that construction is very low at the bottom. It's second to last, only above agriculture and hunting. So in the construction sector, we're actually just a bit better than farmers and hunters. How can that be? Well, I guess lots of you who are listening, they do have digital files that they created on buildings and on cities. So how willing are you all to share these files? Maybe not very willing because you put lots of work in it and you want to be sure that someone is paying you for this work. So at the moment when you share your file, you can never be sure what happens to it and if somebody's not making more money out of it than actually you should be doing. So this is the technical and organizational question, how data and information is shared in our industry, how it's shared across teams within your company, but also how it's shared with the companies you collaborate, with the engineers, the HVAC experts, and the construction guys. How can we share this data so everyone's participating? The challenges that are associated with the sharing of information and digital collaboration are actually related to trust and related to the high cost that it takes you to build this network of people you know you can trust and who are not going to sell your work and make the profit on it. So on the other hand, we have this new innovation. We have the blockchain technology or distributed ledger technology, DLT, how it's often called, and it offers new possibilities. It promises to ensure that your data is secure, it's decentralized, and it's immutable. So nobody can tamper with it, or if someone alters it, you will know it. Doesn't that sound great? So what my talk is about, I want to touch on 3 topics. First, I briefly explain what the blockchain technology is. Then I look at the state of digitization in the AEC industry. And last, at blockchain scenarios in the AEC industry. It all started with cryptocurrency. Blockchain is the technology behind Bitcoin, the electronic money. In 2009, a mystery character, nobody knows who he or she or this group of people is behind the name of Satoshi Nakamoto, published a paper that was called Bitcoin, a peer-to-peer electronic cash system. The problem that was solved in this paper was how to trade currency without an intermediary, which solved the double spend problem. So if I have a digital coin and I transfer it to my friend Andrew, how can Andrew make sure that I don't keep a copy of this coin and transfer it to Helen at the same time, which would render the value of the coin Andrew holds lesser because the same value behind it is split in two. The solution was a network of computers that run the same protocol. They verify the transaction by competing against each other to solve a computational problem. And then the winner gets to write a block on a ledger or a block on the chain, hence the name blockchain. And then that ledger is updated to the entire network, and the computer who solved the puzzle, the winner, earns a reward. So the 4 characteristics of blockchain technology as a database, if you again think about your precious digital file that you created, that you're concerned to share, are 4 characteristics. First, the database is public. It's not owned by anybody. Second, it's decentral. So it's not stored on one single computer where you would have to be afraid what happens if that computer goes down or if somebody decides to shut it off. But it's stored on many computers owned by different people across the world. Third, it's constantly synchronized to keep transactions up to date. So you can always be sure that everybody has the latest version. And fourth, it's secured by cryptography to make it tamper-proof and hacker-proof. Blockchain technology has 2 components. One is game theory, and the second one is cryptography. So the game theory part is that it needs incentives to participate in the network, and that these incentives are designed in a way that make the digital system fault tolerant and secure. So the cost of attacking the system maliciously would require much more work than the reward you can get out of it. So nobody in their right mind or nobody who's thinking economically would get the idea of hacking the system because the cost you're putting into is much higher. And the second part, cryptography, is that the data privacy is ensured as information is shared by participants via a private key and only partially. Then the blockchain protocol works very well for applications like Bitcoin, electronic money, because the event that the computers have to agree on is binary. It's true or false. Either money was transferred or it was not. But if you are an architect and you think about how much it takes to get to agree with your client on what design is good, you may already think that this binary situation hardly ever occurs. So difficult for the blockchain are exactly such scenarios. It's situations where even with a trusted intermediary, settling a negotiation is ambiguous. So for example, if you need third-party expertise like that of a lawyer or that of an architect who says this design is better than that one for XYZ reasons. And second, when algorithmically specifying the negotiating rules and the output of the contract terms of a task is difficult. So here we get into the whole field of contracting and what to put into a contract, which is a field currently not very well researched. So the challenges in finding blockchain applications and designing this distributed ledger that can store the value of your digital file, transfer the value and manage it is to clearly understand those specific mechanisms of negotiation and the performance expected of the contract, the theory of the game. Although it's very complicated, there are applications that go beyond cryptocurrency. There are colored coins that certify proof of existence for certain physical or digital assets. For example, an object or a person gets a digital identity that's stored on the blockchain, title deeds for real estate, use rights for software or intellectual property. There's smart contracts. Those are computerized transaction protocols that execute the terms of a contract enacted by blockchains. So imagine I'm living in China now. So imagine I'm shipping a container full of flowers to Germany, to my home country. I would need to write a series of contracts. I would need to agree with the buyer, I'd need to agree with the shipping company, and I need to agree with customs on both ends. So imagine you can put these contracts on something like the blockchain so all the participants can see the status of the shipping and then transfer money accordingly to the status. That would make things a lot easier. Then there's decentralized autonomous organizations, or DAOs. Those are sets of smart contracts. There's this New York-based company, Consensus. They're running this experiment now where they basically got rid of a traditional management and a traditional hierarchy. So all the contracts they're working on are put on the blockchain, and then their employees or whoever wants to participate get to decide what kind of projects they want to participate. They specify how much work they want to put in, what their deliverable is, and what kind of salary they want to draw from it. So you see, it's a huge experiment, but it also has the potential to change the economy and how organizations work. Of course, blockchain technology has its criticisms, it has its risks, and there are limitations. One of the biggest criticisms is energy waste. So I've already mentioned this proof of work that computers need to render when they're competing against each other to write a block. That uses lots of energy. So for the Bitcoin blockchain, people have calculated that in 2017, the Bitcoin blockchain is likely to use about the amount of energy which is the same as the whole country of Tajikistan. So that's a lot of energy. The biggest merit of blockchain technology is that it got rid of intermediaries. But if there's no intermediary, all the participants are fully responsible for their content. So if you lose your content, there's no one to go to. So I know of a person who had 10,000 Bitcoins stolen. There's nowhere he can go to complain. Similarly, the legal status of digital autonomous organizations is still unclear. What kind of labor laws do apply? What kind of taxation system applies? That's all still uncertain. Then while the blockchain is very secure and uses military-grade cryptography, all these additional programs, the smart contracts that run on the blockchain, are an entry point for malware, which could compromise the advantage of all this cryptography. And then, as I said before, there's limited scenarios where a transaction protocol can actually be programmed in a way that it anticipates all user behaviors. What does all this mean for the AEC industry? And where exactly is the AEC industry on its journey to digitization? Because digitization, having information in digital form, is the prerequisite for putting it on the blockchain. The best source to find out are probably the numerous industry reports and sector reports. And the ones I've looked at so far don't mention blockchain technology yet. Generally, they take a very careful stance towards technology as a tool, and they do so traditionally. I found this quote that I want to share with you in the Egan report, which was written in the UK about 20 years ago. And now I quote, "Technology on its own cannot provide the answer to the need for greater efficiency and quality in construction." And it recommends to approach change by first sorting out the culture, then defining and improving processes, and finally applying technology as a tool to support these cultural and process improvements. So this kind of reflects back on what I've talked about before when I made a point about the game theory part of blockchain technology, much more than the crypto and IT part of it. sector reports in the AEC industry traditionally look at four things. First, they look at the market situation of supply and demand. They monitor the state of the existing building stock, forecast demand for retrofitting, demolition, and new construction, as well as the overall economic and demographic, ecological, and technological developments. Second, they're concerned with the efficiency of the work process, so they analyze the effects of regulatory tools on the value chain. And third, they're concerned with the effectiveness of the work process. Here they look at the quality of the built environment, so actually all the work that we render, what kind of buildings does it create? And fourth, with a more long-term view, they look at skills and education to assess the capacity of the future workforce, which is a topic very dear to my heart as a professor and an educator. Current frontiers the architecture, engineering, and construction industry is facing is the digitization of design, of the engineering and the construction. And here a very big effort is made towards encouraging firms to use BIM, building information modeling, in their workflow. In Europe, we see that firms do use the digital tools. They use AutoCAD, ArchiCAD, SketchUp, but the organization of teams and projects remains unchanged. That means if architects in Europe draw a line on AutoCAD, they do it just exactly as they would do it with ink, a ruler, and a piece of paper. Why is that? First, there's a lack of education on both ends, both on the end of firms, the end of the management, and at the end of the workforce. So architects sometimes don't understand the full capacity that digital tools give them. And then on the other end, managers and company owners, they don't see into the digital potential deep enough to integrate it into their business plans. Then there's no perceived benefit of fully digitizing because the projects are small, they're complex, and they're unique. So it's hard to reach economies of scale. Then clients don't even request BIM. And last, the cost of investing in BIM structure is enormous. And if there's no reward, then nothing's going to happen. If we compare the situation in Europe with China's AEC industries, we see some differences. In China, we have very large-scale design and construction industries, whereas in Europe, most design and construction firms are very small enterprises with 3 to 7 people. And the large Chinese design and construction industries, they can allocate much more assets to establish groups who drive digitization. Then in China, there's increasing requirement of local and national governments to digitize processes. For example, BIM is going to be compulsory in the city of Shanghai by the end of this year. And there's a hierarchical organization of teams that makes it easier to assign clear roles to designers, engineers, and builders and educate them specifically. Then large-scale design and construction institutes often work on large-scale projects. So if a company is doing a lot of housing projects, they are most likely very similar because they compete in the same market. And that helps these design companies to realize the benefits of scale from the investment in digital infrastructure. So overall, the outlook on China's AEC industry with regards to digitization is much more rosy than the one back home in Europe. So how far are we from actually implementing blockchain technology in the AEC industries? Industry reports remain silent. The blogosphere is very active, but bloggers are ambivalent. There's some who are pessimistic because they point to the slow speed at which the industry has previously been setting up standards for digital cooperation and the scaling effects necessary. But then there's also bloggers that are very excited about chances to cut administrative costs that have come with digitization, particularly the protection or licensing of intellectual property rights. So here's again your piece of digital file that you're afraid people are going to steal off you. And that's actually also in line with the implementation of BIM, which is going on now and doesn't have to do anything with the blockchain yet. Then bloggers are further excited about the chances to build reputations on blockchain. So you know how important it is for an architecture office to have a good reputation, to find a good client. But then more often than not, the success of a project doesn't depend on one single design firm, but it depends on the larger network in which the project is created. It also depends on the engineers you get to collaborate with. It depends on the contractors. It depends on the builders and on the material suppliers. So once you can put this more complex reputation of a whole network of firms on the blockchain, effects will become clearer. Then bloggers are further excited about all the possibilities in the realm of the Internet of Things. Here we imagine that building components will be equipped with sensors that report and store performance independently from the manufacturer. And then if there is a malfunction or if there is a change in expected performance, through smart contracts, those building components could schedule their maintenance independent from a service company's judgment. And then the last point is more long-term. If all this data is archived on blockchains, we will have a much better basis for evaluating, planning and design decisions, and improve industry standards and training curricula. So there's a lot of stuff to get really excited about. To conclude, we've already seen that the application of blockchain technology requires a deep understanding of the actors in this space, their interests, and the collaboration processes to design this fault-tolerant digital system for secure transactions that create better buildings, because that's what we want, better buildings. But to make economic sense, blockchains need to replace intermediaries at lower prices. Therefore, it's necessary to identify and better understand the role of intermediaries and what value they add to the project and at what costs. So application scenarios that we can imagine today are likely in the segments of the value chain that can be expressed with algorithms like reporting, monitoring responsibilities, and transferring risks. So to conclude, I want to come back to this chart of McKinsey & Company, where the construction industry is faring so dismally bad. But looking back on what I just said, I'm very confident that we as an industry can improve and that we can move up a couple of notches within the next 5 to 10 years. These are the main points of my recent research. Thanks for your interest. And if you have any further questions, please contact me.